Greetings, Tech Voyagers! Welcome back to Space Science Tech, where we dive into the realms of space, science, and technology. I'm your host, Johnny Demonic, guiding you through the cosmic dance of data and code. Today, we're exploring a fundamental tool in the Network Administrator's Toolkit, the ping command. Before proceeding with the use of these commands, please ensure that you have explicit permission to scan the network. Unauthorized network scanning can be illegal and unethical. These tutorials are conducted in a controlled lab environment. Always use these tools responsibly on networks where you have authorization, such as your home network or a dedicated lab setup. Stay ethical, stay legal, and happy learning. Imagine this: you're a network administrator, and you need to check if a specific device on your network is up and running. Or perhaps you're an ethical hacker, probing the status of a network device. The tool for this task is simple yet powerful: the ping command. The ping command works by sending out ICMP echo request packets to a target device and waiting for ICMP echo reply messages. It's like sending a sonar pulse out into the network and waiting to hear the echo. This process helps network administrators verify connectivity and diagnose network issues. A successful ping means the target device is alive and responding. If there's no reply, it could indicate the device is offline, unreachable, or there's an issue with the network path. But the world of ping doesn't stop there. There are several variations of the ping command, each with its unique capabilities. Fping: this command can ping multiple hosts simultaneously, making it efficient for network scanning. nping: provided by Nmap, nping offers advanced features such as custom packet crafting and detailed timing information, useful for network diagnostics and security testing. Do-ping: a tool designed to handle more complex ping scenarios, offering additional flexibility and functionality. Network administrators use these commands to monitor network health, troubleshoot connectivity issues, and map out network topologies. Adversaries might use them to identify active devices and potential targets within a network. Let's dive deeper into the tools at our disposal on Kali Linux and Parrot OS. Here, I've used the witch-ping command to locate the ping utility on our system. As you can see, it's located in the /usr/bin directory. Now, let's change directory to /usr/bin/ and list all files related to ping using ls-al pipegrep ping. Notice that several types of ping commands are available pre-installed, including ping, fping, and nping. To understand the differences between these commands, let's consult ChatGPT. ChatGPT is an excellent source of knowledge, providing a concise comparison of ping, fping, and nping. Ping: the standard network utility used to test the reachability of a host on an IP network. It works by sending ICMP echo request packets and waiting for echo reply packets. Fping: unlike ping, fping can send ICMP echo requests to multiple hosts simultaneously, making it much faster for network scanning. nping: part of the Nmap suite, nping offers advanced features such as custom packet crafting, which can be useful for both network diagnostics and security testing. While ChatGPT provides a great overview, remember that the man pages for these commands are your go-to resource for in-depth information. You can access the man pages by typing man ping, man fping, or man nping in your terminal. These pages offer detailed descriptions, options, and examples that can help you master these powerful tools. It's crucial to use the manual, or man, pages to learn more about these powerful, free tools and how to properly use them to scan a network. The man pages provide detailed information on usage, options, and examples, helping you to fully understand and utilize these tools effectively. As we continue our journey through the realms of network reconnaissance and cybersecurity, it's crucial to understand the tools at our disposal. stay curious, keep learning, and always dig deeper into the documentation. Now, let's explore another powerful ping tool available on Kali Linux and Parrot OS, the do-ping command. This command allows us to ping every IP address on our network efficiently. In this first example, we're generating a sequence from 1 to 254 for the last octet of our Class C subnet. This approach allows us to target each possible IP address within the range. Notice how the command is structured to iterate through each IP address and send an ICMP echo request. We can filter the results to only display the responses from devices that are alive by appending pipegrep 64 bytes. This way, we only see the positive echo replies, showing us the IP address, sequence number, TTL, and the response time in milliseconds. In this second example, we take a slightly different approach to generate the same sequence. This variation demonstrates the flexibility of do-ping in handling different scripting methods. Again, we use pipegrep 64 bytes to filter the output, ensuring we only see the successful pings. This command helps us quickly identify which devices are alive on our network. Here you can see the results. Each line indicates a device that responded to our ping request, providing essential details such as the IP address and response time. This method is extremely useful for network administrators and cybersecurity professionals to quickly map out active devices on the network. To wrap up our exploration of ping tools, let's harness the power of Python to scan an entire subnet. This script will iterate through the last octet of our Class C subnet, just like we did in our previous examples. Python is incredibly versatile, allowing us to automate tasks like network scanning efficiently. Here, we've written a simple script that uses the ping subprocess to scan all devices on our subnet. This script runs a ping command for each IP address in the subnet. If we get a 64 bytes response, it means the device is alive, and we print the IP address. Let's run the script and see the results. Depending on the number of hosts on the subnet, this process may take a few moments to complete. As you can see, our script successfully identifies the active devices on our network. This approach is both powerful and customizable, making it a great tool for network reconnaissance. Now, let's compare our results with a sudo arp scan. This tool is another great utility for identifying devices on a network. By running sudo arp scan, we can see a detailed list of devices on our subnet, including their MAC addresses and manufacturers. Comparing the results from our Python script and arp scan, we can see that both methods effectively identify the active devices on our network. Each tool has its strengths, and together, they provide a comprehensive view of our network environment. In our journey of mastering space, science, and technology, understanding how to use ping and its variants is crucial. Whether you're ensuring your network's stability or probing for weaknesses, these commands are indispensable tools in your arsenal. Stay tuned as we dive deeper into the technical aspects and practical applications of these commands in our next segments. Keep exploring, keep coding, and may your networks always be robust and secure. This is Johnny Demonic signing out, my fellow code-slinging cybermancers. Don't forget to like, share, and subscribe, and hit that notification bell to stay updated with our latest tutorials. See you next time on Space Science Tech.